And we're back, everybody. Welcome back to another day of Mr. Labrick's Algebra 1 class. Today is Tuesday, March 3rd, 2020. Now think about this, folks. If you go back 15 years from now, this will probably still be on YouTube.
Oh no.
You know,
years ahead.
Yeah.
15 years.
No, 15 years from now. If you look back, no, that's not what I said. I said in 15 years, if you look back, this will still be on YouTube probably somewhere.
You said probably.
Probably. I don't know what's going to happen. Probably be on YouTube. Maybe they'll purge all of the bad videos off YouTube and all mine will be on.
I'm sweating.
No, all yours will stay on.
I was watching. Thank you. Oh.
Yeah, they'd always be the top unrecommended.
Yeah.
Watch all these.
So when your kids are going through Algebra 1 and you're like, man, I wish they could have Mr. Labrick as a teacher. It's like you could just play the videos and be like,
Don't pay attention to your teacher. Watch these videos.
think about what education is going to look like 20 years from, when you have kids going through high school. We'll be coming half days. It'll be like college where I'll have office hours and I'll be teaching online and there'll just be a webcam up.
Yeah, the cancer.
I would just like you to know I will still be subscribed.
Thank you.
You have to constantly tell Jimmy to be off the phone.
All right.
We'll see because I don't ever go on YouTube anymore.
So you'll just leave it. It'll just be there. All right. So we're doing section 9.2 today. Characteristics of quadratic functions. Now, can somebody tell me what a quadratic function is? What is it? What are things that we learned yesterday about quadratic functions? We learned a lot of different things. What's one of the things that we learned? Oh, you're just reading off your definition. But what do we know? What do we know about a quadratic? What does it look like? Y equals ax squared plus bx plus c. That's standard form of a quadratic, right? Okay, so what, in terms of looking at the equation, how do you know a quadratic is a quadratic? What do you look for when you're looking at an equation? Noah? An exponent, an exponent of 2, a squared term, right? Okay. In terms of a table, what's that test that we talked about? The second difference test, right? If you find differences within differences, then you know, and it's constant, then you know that it's quadratic. What's the shape of the graph look like? That parabola. A smiley face. Or, now how do you tell whether it's a smiley or a frowny? The negative out front. Negative out front is frowny face, right? Those are math terms. If anybody was wondering out there on YouTube, those are math terms. Frowny is a downward shaped parabola. Yeah. All right. So that's what we talked about yesterday, right? And we talked about, what's that topping out or bottoming out point called? Vertex, right? Also called the minimum or maximum value if I just ask for the y value. Anything else that we learned yesterday? Oh, domain. What's the domain of all parabolas? All real numbers. What does the range depend on? The vertex, and whether it points upward or downward, right? Right, good. Okay, so let's talk about section 9.2. There are other characteristics that we know on a quadratic. The first one is called a zero of a function. Guys, that is a very, very, very important term. A zero of a function is an extremely important term. Okay? Go ahead and underline that definition. It's an x value that makes the function equal to 0. It's the x value that makes the y value 0. It is any x value that makes the y value 0. Guys, let me ask you a question. What type of coordinate did I just write on the board? Everybody look at that coordinate. What type? That's got a special name.
X-intercept.
An x-intercept. So, remember we talked about that idea of synonyms, right? Words that mean the same thing. X-intercept and zero of a function mean the same thing. Okay? For our purposes right now, x-intercepts are zeros of a function. Okay? That's another thing that the test likes to do at you, or to throw at you, right? Got my words mixed up. They like to throw at you different terms and to see if you know what they mean. So they'll say, okay, find the zero of that function. What are they really talking about? The x-intercept. Right? So that's another thing. Okay? Wherever it crosses the x-axis, that's a zero of a function. Okay, so We got x equals 0. Okay, good. Where are the zeros of this first function? Where are the zeros of this first function? Jack. Good. -1 and 3. Guys, I would accept that as a single term, -1, 3, or if you wanted to give it to me as -1, 0, 3, 0, that's fine as well. I would accept just -1 or +3. Like if you wanted to just give me that, that's fine. You know what I don't like? When you guys do this. Because what does that look like to me? A coordinate, right? When we're talking about graphing, please don't separate your answers in terms of commas. Please don't do that, okay? So just give it to me as two separate things, not separated by a comma, or two coordinates. I like to write them as coordinates because they mean the same thing as x-intercept, right? Okay. So we have two x-intercepts. Where does this cross the x-axis? It bounces off of it where? At -4, 0. Does it cross? So we could say -4 or -4, 0. Either way, either answer is fine with me. But does it cross anywhere else? No, it doesn't cross anywhere else. Okay, so this one has 1, 0. How many zeros does this one have? None. Does it cross the x-axis? You may be thinking, whoa, it crosses that one. No. Well, what's that? Yeah, that's the y-axis. That's a y-intercept, not an x-intercept. There are no zeros. Okay. Now, do you see that space? We kind of left that space open where it says a quadratic function may have 1, 2, or no zeros. Can you draw yourself a little diagram for me right now? This is 1, 0, where it bounces off. Okay? Just a crude little diagram. This is 2 zeros. This is what we normally have. Make yourself little dots there. And this is none. It's not going to cross at all. Okay? Right underneath the statement, the quadratic function may have 1, 2, or no zero. See this space?
Yeah, I was thinking it.
Okay, the space provided.
We only moved down, we didn't move up.
I wanted to do the examples first. Okay, whatever. Okay. All right, so there are three options that you could have. A quadratic could have 1, 0. It could have 2 zeros. It could have no zeros at all. Okay, those are your three different options that you could possibly have. All right, so now this is kind of a side note. This is a kind of something that you'll get in Algebra 2 land eventually. There are times when we have certain functions that look something like this. Okay, certain functions have more zeros. Like for example, this one would have how many? That one would have 5 different zeros, okay? So when you get to Algebra 2, you learn about functions that don't just have 2 zeros. They may have 3, 4, 5, 6, a lot of different zeros, okay? So that is a possibility out there. All right. Okay, a vertical line. Another key part of any parabola is that vertical line that splits a parabola in half. The vertical line that divides the parabola into two symmetrical halves is called the axis of symmetry. Axis of symmetry. Your axis of symmetry is basically your midline of your parabola. Every single parabola must be symmetrical. You know, back in like elementary school, you did like lines of symmetry. You put a dotted line down the center of whatever was symmetrical, right? Parabolas are like that as well. Okay, so we're going to do that exact same thing where we put a dotted line down the center. Okay, now we can use the zeros to find the axis of symmetry. Why? Because the zeros should be in the direct center, or the zeros should show you the direct center of the graph. So our first option is when we only have 1, 0. Okay, when we only have 1, 0, that is the vertex point. That's where that dotted line is going to run exactly through. Okay, so look. X equals 3. That's our axis of symmetry. Box that for me real quick. X equals 3 is our axis of symmetry. X equals 3. Yes, X equals 3. That is a vertical line. X equals. Okay, that vertical line, X equals 3. Every single axis of symmetry is going to be an X equals. Take a look at the 2 zeros option. The 2 zeros option, if you got two different locations where it's going to cross the x-axis, in the direct center of those two things, those two numbers, those two values, will be your axis of symmetry. So if I've got 4, negative 4, if I've got negative 4 and 0, what's directly in between negative 4 and 0? Negative 2. The average of those two, right? 0 plus negative 4 is negative 4, divided by 2 is negative 2, right? It's halfway through. There is my axis of symmetry. X equals 2. That makes sense? Okay, let's try some of those. Flip your page over there. Okay, everybody drawing your axis of symmetry. You know, let's do this. Let's take a moment and do all 4. Draw in all 4 axes of symmetries. I don't know if that's correct terminology. Draw a dotted line through the center line of your graph. Draw a dotted line through the center of your parabola for each one of these 4. Okay, did we draw it here? Yeah? Now, everybody, right next to part A, we're going to write x equals, and then what is the number that we ran through? Negative 1. Negative 1. X equals negative 1. Guys, I'm going to be extremely picky about this. You need to write x equals. If you just write negative 1, taking off points. So maybe it might be a good idea to write now for the rest of your 4 problems just to write x equals. Get them set up. Okay, where is my dotted line in this case? What's that? 1.5? Well, I would disagree with that. It's 2.5. Yeah. How do we know that? Well, just count it. 1, 2, and half. But another way to do that is, what are my 2 zeros? 1 and 4. What's halfway between 1 and 4? 2.5. Yeah, let's look at part C there. Looks like right here. Let's double check that. X equals, what do we think? 1. Let's double check that at 1. I've got negative 2 and positive 4. What's negative 2 plus 4? What's negative 2 plus 4? 2. Divided by 2 is, Piper? There it is. 1. X equals 1. X equals 1. Yeah, I know. I see what you're getting at. I'm picking up what you're putting down. All right, question about that. Oh, there's another one. I'm sorry. Sorry. And so here's my line of symmetry. It runs all the way through. X equals, what is it, folks? -3. Look, I chose a blue pen.
The dry erase board, like when you go with your fingernail. What? Like when you draw.
When you draw on it,
yeah. God, Piper, you're so toxic.
All right, here we go. Another key piece here using the axis of symmetry. Okay, so what if we're not given a graph, right? That's given a graph, but what if we're not given a graph? What if we're only given the equation and asked to find the axis of symmetry? Well, then life gets a little bit more difficult, okay? Here is the equation of the axis of symmetry. Folks, start committing that one to memory. X equals -b over 2a. X equals -b over 2a. Say that with me. X equals -b over 2a. Thank you. -b over 2a. -b over 2a. This is the equation of the axis of symmetry. Where do you think A and B come from?
I was gonna say that joke.
You're so funny. The alphabet. Oh my gosh, I'm dying laughing.
I can't wait. Never. That was it.
From the equation, ax squared plus Piper. Awesome. Thank you. Ax squared plus bx plus c. A and B come from right there and there. As long as it's in standard form, you should be able to pick out A and B. So let's try this. All right. So what we're going to do first, so look at the question here. Find the axis of symmetry. Every time we do these problems, I want you to write out your original equation. So for right now, we're going to write it 3 extra times. X equals -b over 2a. Okay, now, let's identify what A and B are. Okay, what is A? -3. What is B? 10. Good. So that means this is -10 divided by 2 times -3. Now follow me here. So that means it's negative, well, what's 10 divided by, well, what is 2 times -3? -6. Let's put it as a fraction. -5/3. So it's -5/3. What happens to my 2 negatives? They cancel out to become a positive. So +5/3. So x equals 5/3. That's my equation of the axis of symmetry. You guys follow me there? Do another one. I'll leave that work up there so we can see it. Okay, what are you going to do first off? Write the equation. X equals -b divided by 2a. That's the best way to memorize it, folks. Write it out, write it out, write it out every single time. Okay, what's A? 2. What's B? -1. So that means it's -1 divided by 2 times 2. Well, what is 2 times 2? 4. So this is 1/4. So -1/4. What happens to my 2 negatives? +1/4. X equals +1/4. So my midline is at 1/4. Let's do one more. Okay, we've got x equals -b over 2a. Okay, what's A? What's B? Okay, so this means we've got negative 4 divided by 2 times 1. Okay, I've got negative 4 over 2. What is negative 4 over 2? Negative 2. What's going to happen with our two negatives? They're going to cancel. Left us with a positive 2. X equals positive 2. Okay, guys, we're going to keep going. Don't worry. We're going to keep going. We still got 5 minutes left. Relax. Okay. So what we're going to do here now, we're given the equation of the axis of symmetry. We're given the equation of the midline. Guys, looking back at the graphs of all of these, doesn't my axis of symmetry run through my vertex for every single one of them? So what do you think the x coordinate of the axis is, or sorry, the vertex is? Like if I were to pick out the vertex right here, what's the x coordinate? -1, 0, right? If I were to pick out my vertex right here, what's the x coordinate? 1. If I were to pick out the vertex, -3, what's my... So what am I getting at here? The x coordinate of your vertex is your axis of symmetry. It has to be, because doesn't your vertex always go through on that axis of symmetry? So, how do you find a vertex? Well, you basically get it when you solve for the axis of symmetry. How do you find the y value then? Well, that's step 2. Everybody underline that part. Substitute the x coordinate of the vertex into the function. You just showed me doing those last 3 problems that you can find the axis of symmetry. So if you can find the axis of symmetry, all you have to do is plug it in. Last step, really? Last step, just write it as an ordered pair? Come on now. Put it as a coordinate. So let's try one. Let's find the vertex. Yes? That's okay. You don't need the graph here. Here, let's do it like this then. Gone. I gave that to you so we could estimate it, but we don't need to estimate it. What's my A value? What's my B value? Okay, so we've got x equals -b over 2a. You may be thinking to yourself, oh, Mr. Laverick, you're reading this wrong. This isn't find the axis of symmetry. This is find the vertex. You do the same thing. So we've got -2 divided by 2 times 0.25. Okay, now I'm going to go into my calculator and run that. 2 divided by, parenthesis, 2 times 0.25. 4. -4. So you know what I'm going to do right now? The x coordinate of my vertex is -4 comma something. Because that's the axis of symmetry, right? That's the midline of the graph. I know my vertex has to lie right on that midline. -4 comma something. Where do I get that comma something? Plug it in. 0.25 times -4 squared plus 2 times -4 plus 3. What did I do right there? I'm just plugging in -4. Just plug it into the equation. You take this and you plug in -4. So let's go into our calculators and do that. 0.25 times -4 squared plus 2 times -4 plus 3. -1. And that's where the y coordinate of the vertex comes from. Okay. We'll do the rest of the guided notes tomorrow. Okay? You should have everything you need for the homework tonight. Everybody say bye to YouTube.
Bye. Subscribe.